In this lab, in the Department of Mechanical Engineering at the University of Sheffield, a prototype device is being tested which, as far as I'm aware, is the only one of its kind in the world. The device is called a semi-active helical inerter, and its job is to control and suppress unwanted mechanical vibrations. Inerters first found use in Formula 1 racing, where they were called J-dampers, and have been used by the McLaren team to improve their suspension since 2005. Recently, the technology entered the public domain, and there's been a drive to adapt the design to create inerters to remove unwanted vibration in other areas, such as civil engineering and machining science. Inerters come in a few different varieties, depending on the method they use to create inertia. This type is called a helical fluid inerter, because it creates inertia by pumping fluid out of the piston, through these helical coils of piping, and back in at the other side. This inertia can change the dynamics of the system in a useful way, with careful design and a few calculations. Normally, this type of inerter is filled with either water or hydraulic fluid. However, this one instead contains something called magnetoreological, or MR, fluid. This contains a high percentage of magnetic particles. Increasing the current from this controller, which is connected to an electromagnetic valve in this pipe, causes the particles to line up. This increases the yield stress of the fluid, meaning the piston has to apply more pressure before it will start to flow. Because MR fluid reacts incredibly quickly to changes in the magnetic field strength, we hope to create a highly controllable device which can react to changes in the system on the fly. This device is a prototype in its early stages, and we're still exploring its potential and limitations, using a mixture of computer models and physical tests like this one. There's still a long way to go before we'll have anything approaching an optimal design. However, the data we have so far are promising, and, hopefully, with a few more years' work, we'll have something which is ready to be used in industry.